Okay, so this is the next question number 9a. We have given the following information, so let me write the information down. K, L, M, N are points on the circumference of a circle, and we got xy as the tangent, and you got LKY 48 degrees, MKO 12 degrees, XKN 56 degrees. You have to find the angle KOL, and the question specifically states giving reasons. Okay, giving reasons for each step. Okay, so they are asking you to actually write everything in detail. You cannot skip any steps. Okay, having mentioned that, let me draw the figure. This is the center. I'm going to mark it as O, and there is this tangent. So from the center there is a hit, and from this point there is again another hit, and there is a hit over here, and this is N, this is M. From M there is a hit again, and then from O there is a hit, call it as L. From L there is a hit again. Okay, so it's a beautiful figure. X, K, Y. Now this angle is 48. This angle is 12. This angle is 56. They want to find KOL. So they want us to get this angle, KOL. Okay, this angle is required. Okay, so having mentioned that, we have to state our properties. Okay, so let me move on. First, this is a solution. So the first geometrical law from geometrical property, we know that the radius makes an angle of 90 degrees with the tangent to the circle. Okay, this means OKY is equal to 90 degrees. So this is 90, right? Now since LKY is 48 degrees and OKM is equal to 12 degrees, therefore angle MKL, I'm looking for this angle. Okay, I want this angle, so angle MKL is equal to angle OKY minus the sum of, so from 90 degrees I'm going to take away LKY, angle LKY plus angle OKM. Okay, I hope you got the picture. So this is 90 degrees negative 48 plus 12, which is 90 negative 50 60, which is 30 degrees. So therefore angle MKL is 30 degrees. MKL, so this is 30. MKL. Okay. Now you might be asking, why do I really bother to get MKL? Because I want to know what is OKL. Okay. So this means OKL is equal to 12 degrees plus 30 degrees is equal to 42 degrees. Okay, so this entire thing is 42 degrees. Now you may be again asking me, what big deal? Okay, that you have got OKL as 42 degrees. What is the big deal? Now you see here, OK is a radii and OL is a radii, right? So that means what? OKL is an isosceles triangle created by OK and OL. Okay, I'm exactly going to write that. Since OK is equal to OL is equal to radius of the circle, and angle OKL is created with sides OK and OL and KL, with OK being equal to OL, implies angle OKL is an isosceles triangle. So what is the meaning of this? This means angle OKL will be equal to angle OLK, which is nothing but 42 degrees. So this is the same side. OK and OL are same side. This is 42. So since they are isosceles, this angle is 42. This angle will also be 42. Okay. Now we want to find KOL. So therefore, write it here. KOL is equal to, I'm using the law of the triangles. Sum of the angles in the triangle is 180 degrees. So from 180 degree, you subtract 42 plus 42. So what is that? 84. So from 180 you subtract 84 degrees. So what do you get? 180 minus 84. 10, 6. From 7 you borrow 1 and then that becomes 9, 96. So 96 degrees is KOL. Since NKLM is a cyclic quadrilateral, it means angle NKL plus angle LMN is 180 degrees. But this NKL is 76 degrees. 76 degrees plus LMN is equal to 180 degrees. So LMN is equal to 180 minus 76. From 180 you take away 76. 10 you 4, and this is actually 7, right? From 7 minus 7 is 0, so 104 degrees. So LMN is 104 degrees. Okay, so this is the second part, part B. You've been given E, F, G, and H points on the level ground. The diagram below gives information on the distances and angles between the points. Okay, so let me draw the diagram. This is H. You have north. This is north. This is E. This is F. This is G. This is 5.3. This is 54 degrees. We are given this as X. This is 11. 6.10, all in meters, 11 meters, 6.9 meters, so on. So now we are asked to show that X is 29.5 degrees. Okay, so this is correct to 1 decimal place. Now this is X. So what we are going to do is we are going to consider triangle GHF. Okay, so this is H, this is G, this is F, this is 6.9, this is 11, and this is 5.3, and the angle over here, the angle that is connecting F with H and G with H, this is X. Okay, so we are expected to get this value of X. So what we are going to do is we are going to use cosine law. By cosine rule, we know that. So what do we know? We are going to start with this. GF squared is equal to GH squared plus HF squared negative 2 times GH times HF times the cos of the angle that is between GH and HF. So GF is 6.9 squared, GH is 5.3 squared, and HF is 11 squared minus 2 times 5.3 times 11 times cos x. So we will have to use calculator to get the value. So 11 squared is 121. Now 5.3 squared, that is 28.09 plus 121, 14, or I would say 149.09. I'm going to move it to this end. So minus 149.09 and 6.9 squared. 6.9 squared. 47.61. So you subtract 149.09. And that is negative, but apparently you will have to, okay, that's fair enough. So this step is going to be negative 101.48, and we have to evaluate this step. So this is 2 into 11, 22 multiplied with 5.3, that's negative 116.6 times cos x This is equal to negative 116.6 times cos x. Negative negative cancels. So therefore cos x is equal to 101.48 divided by 116.6. So find that value out. 101.48 divided by 116.6. What do you get? You get 0.870. This is cos x. Now x is equal to cos inverse of 0.870. So let us go to arc. So this is the arc value here. So shift cos inverse of 0.870. 29.54. See that? It's only one decimal place. So x is equal to 29.5 degrees. So clearly, if you see here, we have done step by step the evaluation. Okay, so you get full marks for this. So that is the end of this particular question. Now this is the next part of this question. So let me write the question out. Vertical tower GT is constructed at the point G and is pivoted to the ground and the points E, F and H using pieces of wire. The angle of elevation of the top of the tower T from the point F is 31 degrees. Find the length of the wire. Okay. So what is the understanding of this question? Let's see that. So now this is ground. Okay. They have a tower that they are erecting vertically. So you have this tower going up like this. Okay, you can only construct towers like this, vertical towers. They have to be straight. Okay, so that means they are making an angle of 90 degree here. Now what they are stating here is the point, okay, the tower GT is constructed at the point G and is pivoted to the ground at points E, F and H. So that means from here we can always have connectivity from the top. So this point is T, top of the tower, and we can always have multi-level connections from the top of the tower T. Already there is a connectivity from T to F, and they are saying that it can also be connected to points E and H. So that is not in the question's frame, but it is actually mentioned that there is a possibility, but we are not going to be worried about that. Now what we are going to be concerned is they are asking us to actually get the length of the wire. Now as I mentioned to you, this point is G, ground. From ground you have the tower going up, and there is this point F, and we are interested in getting this length of the wire. So there is a connection there. They are also saying the angle of elevation is 31 degrees. Now we know this length GF is 6.9. okay, but we want to know this. I'm going to take it as some L. Now this is 90 degrees. This is opposite side. This is adjacent side. So what is the formula that connects adjacent with hypotenuse? Cos. So cos theta is adjacent side divided by hypotenuse. Right. So adjacent side is 6.9. So cos theta is adjacent divided by hypotenuse. Adjacent is 6.9 and we need this length. Okay. And theta, what is theta? Theta is 31 degrees. Okay, so theta is 31 degrees. So therefore cos 31 is 6.9 divided by L. So therefore L is equal to 6.9 divided by cos 31. So what is that going to be? First find out cos 31. So 6.1 divided by 0.8. I'm going to take it as 6. So 6.1 divided by 0.86. How much is that? It's going to be 7. We are getting 7.9. So we will have to check this measure. So this is approximately around 7.09 meters. Okay, so you can simply state here, therefore the length of the wire used to secure the point T to the point F is actually 7.09 meters. Okay.